Hi, my name is Seth Schneider, and I'm a software engineer here at Intel. In this tutorial, we will be looking at a frame captured from our favorite DirectX application, City Racer. To start off, let's assume that we've already found out that our application is GPU-bound in System Analyzer, and that we've captured a frame and are now ready to analyze that frame in Frame Analyzer. The first screen that you'll get to is the Open Frame Capture dialog. Here, you can see all the previous frames that you've captured in the past and that you can open up for analysis. Let's open up this first frame, which is the City Racer frame that we recently captured. Since we captured it on this machine, we will be doing the analysis on the same machine that we took the capture from. Essentially, our host and target are the same machine. You'll notice the bar on the right-hand side. This bar indicates how long it'll take for the frame to load. Once the frame is loaded, you will notice four major panes. The first pane is the erg graph. This graph displays all the durations of each of the ergs. We'll get to what exactly is an erg in a minute, but for now, let's just go through a tour of all the different panes. The next pane is the render target viewing pane. This pane displays the render targets that are currently selected. Next, we have the scene overview pane. The scene overview pane displays the ergs in a tree-like format. And last but not least, we have the erg information pane. This pane displays information about a particular erg. First, let's start with the erg graph. So what is an erg? An erg is anything that takes up time on the GPU. This could be a clear, a copy resource, a draw, or a draw indexed. Basically, anything that could contribute to the duration of your frame is counted as an erg. So let's discover what is on this bar. The bar's X and Y axis is accessed by GPU duration. We can change this up in the top right-hand corner. We can select from any metric that we'd like. For instance, we could do primitive count on the Y-axis and do no metric on the X-axis. Here, the tallest bars will be the draw calls with the most primitives. For basic optimization, I like to access the graph by both GPU duration on the X-axis and GPU duration on the Y-axis. That way, the largest bars are the bars that take up the most time on the GPU. This is usually where you'll want to start when first analyzing a frame. So, from this bar chart, you can select an erg by just clicking on the bar. We can select any one of these ergs, or we can select a grouping of ergs by clicking and dragging. If we want to cancel our selection, we can hit Edit, deselect all ergs, or we can just simply hit Escape. Next, let's take a look at the render target viewer. Here in the render target viewer, we can select specific render targets. As you can see, under the render target, it says ergs 0 to 1. These are the ergs that this render target is affecting. So in render target 1 here, we see that ergs 2 through 1,764 make up render target 1. We can click on render target 1, right-click, and say select all the ergs in this render target. This will select all the ergs in the bar graph that contribute to that render target and highlight them in the frame. As we can see, it's our entire frame. Let's talk about the render target viewer, though. Here in the render target viewer, we can decide how we want to look at our render target. For example, we can see how the selected ergs are displayed. We can choose normal, which means that there will be no highlighting at all. If we select a smaller portion and then choose highlighted, let's just, for instance, select this one erg, go to the drop-down, wait for it to calculate, and then click highlighted, you'll be able to see which erg that was selected for that scene. For example, we can change it to the car, and the car becomes highlighted. We can then use the drop-down to look at other things, such as wireframe and highlighted wireframe. Other things that we can do are we can do a scrub mode. So we can draw only to the last selected erg. So if we go here, let's turn on normal. And then let's choose an erg about halfway through the scene. It'll calculate and show us what we've drawn up to that erg. We can also flip the render target as well. This is helpful when porting something from OpenGL to DirectX. In the render target viewer, we can also look at the depth and the overdraw. Overdraw is helpful when choosing which exact pixels have overdrawed the most. Then we can use our pixel history later in the tutorial to see where the hotspots for overlap. We can also click this button to extend out the render target viewer and pull over the histogram like so. Here we can clamp our colors and clamp our scene. If we auto clamp, it'll reset. Next, let's take a look at the scene overview. Here in the scene overview, we have a few options. We can view the entire scene's ergs by either selecting regions, ergs individually, or full tree. The full tree splits up the ergs into render targets. If you prefer to traverse the scene from a tree, this is the view for you. In this view, we can see the primitive count, the old duration, the new duration once we start making experiments, the delta, and the change in delta. Here, we can change this metric, though, depending on whatever we want to look at. Here we have GPU duration selected, but we can change this to whatever metric we would like. For instance, we could do EUs active. Here we can see which draw calls invoked EUs and which ones didn't. If we then made an adjustment in our scene, we could see what the change was. In addition, you can also view the API log. If we go to View, API Details, we can see the full API log for the scene. Here we can see which API calls contributed to each erg. For example, if we look at erg0, which is a clear, we can see that these two API calls affected or contributed to this erg. We can see what parameters were inputted into this API call in order to produce this erg. Over on the right-hand side, we can see the details of that API. That way you can correspond the input values to what the API call is actually doing. We also show API statistics. Here you can see the amount of times each API was called and the ratio to draw. Last but not least, we have the erg information pane. This pane is rich with several tabs that give you information about each erg that's selected. First, we have the Frame Overview tab. This tab has metrics based on the entire scene. For example, the GPU duration that is displayed here is the entire GPU duration of all the ergs combined. If we go into the Details tab, we can see information and metrics based on the erg that we have selected. For instance, if we select the car, we can see the GPU duration of that erg. If we scroll down, we can see other information based on that erg as well, such as the EU array, the pipeline, and other important things such as the pixel shader, how many times the pixel shader was invoked for that erg, and so on. We can also look at the textures. Here we will get the associated textures with that erg. As you can see here, this is the texture that belongs to the car. We can also change the MIP levels of that car as well. So say if we change the MIP level to 5, we can see what that texture would look like. We can also look at our states. Here we can look into each stage of the pipeline and see what states were set during that erg. For example, we can go look at the sampler states in the pixel shader. We can see how we're clamped, see our border colors, and so on. Next, let's go to the Shaders tab. Let's select an erg such as this draw call. For this draw call, we can see which vertex shader and which pixel shader are affecting it. If we select the pixel shader, we can view the source code, such as the HLSL, or we can view the IL assembly. Let's view the HLSL and scroll down into the shader. Here's our radial blur filter, which is the erg that which is the shader that this erg is using. If we change the return value to be, let's say, a float 4, and let's make it red. Then we can hit apply, and it will replace the current shader with this new shader that we just edited. As you can see, the whole scene turns red. We can then revert the changes by hitting the revert button. And the shader is back to normal. Next, we have our shader constants tab, where you can see your constant buffers and how they're populated. We can then go over to the experiments tab. This tab is very important and is very helpful for optimizing a scene. For example, if we select our car again, we can then replace its texture with 2x2 textures. The scene will calculate, and you'll see that the car has changed. We can also disable erg, which will completely remove it from the scene as well. So if we disable the car, the scene will be recalculated and redrawn without the car. We can see how much improvement our experiments have made by looking right here. Here we can see the delta and the amount of time saved. As stated previously in the tutorial, we can now see that the old, the new, and the delta fields are populated in the scene overview. Let's turn off our experiments and go to pixel history. Pixel history is very useful. All you need to do is hover over the render target and click. You'll see the gray crosshair on the pixel that we have selected. As we can see, the first erg to select that pixel was the clear render target, then a draw, another draw, and the final draw. So let's see what these are. If we go over to our render target viewer and select highlighted, we can see each of these. So let's take a look at this erg first. We can right click and say select only this erg. This was the road. That makes sense. The road was one of the first things to be drawn. Next, we can select the next erg, and we hit one of the tiles on the road. Last but not least, we can select the last erg and see that we hit the car. Pixel history is useful for finding overdraw. If we click on a building, we can see that some of the ergs affecting these pixels were z-rejected. Next, let's look at the geometry view. Here in the geometry view, we can view our object that we selected. We can change how we view it by either going wireframe, solid, point cloud, and strips. We can also right-click and export the geometry to an OBJ-type file format. Last but not least, we have the API log, similar to the log we viewed before, but just for the erg that we selected. For more information regarding Frame Analyzer, please make sure to check out our documentation online. Thanks for taking the time to learn about Frame Analyzer for DirectX. If you have any questions, be sure to post them in our support forums or check out our FAQ pages. Also, be sure to look for our release videos for the newest GPA news and updates. Thanks for watching.